Get zoomed in. All right, today we're talking 5.6 off the script. 5.6, last section of the unit. That marker's dead like my hopes. So, a rational function is unlike me when I'm angry. I'm just kidding. I was going to make a different joke. So rational is when we have a function over a function, right? So it's a fraction. When you hear rational functions, you're thinking a fraction bar, okay? And now there's some neat things that happen when we deal with rational functions. Let's think about for a second the most basic rational function of 1 over x, okay? 1 over x is our first function we're going to look at that's restricted. What do I mean by restricted? Can I plug anything in that I want into this? No. What can't I plug into this? 0. I can't divide by 0. So when you graph this beast, 1 over x, it does not have a value at 0, right? And then what else can't it equal? What can't this thing equal ever? If I said it equals something, it can't equal 0 either. There's no number I can plug into this to get 0. So do you guys remember what we call those beasts? Those are asymptotes. Some people say dealing with them is a pain in the asymptote. But I say those people are wrong. All right? So what we're going to deal with today is asymptotes. That's really what the story is. We need to be able to find what values don't exist on a function. Now, good news is, it's honestly very straightforward to do this. Okay? This is a very straightforward type of problem. There's going to be 4 steps we follow every single time we see a rational function. Or there's 4, how about this? There's 4 things we have to find to graph a function. So I'll give you the 4. So if I were you, I'd make like this chart. And if you have this chart, you can do any problem that you will see in this unit from here on out. All right? So we're going to do 4 quadrants. So, wow, that was good. So, step 1, when we're dealing with a rational function, I want to find vertical asymptotes, okay? And again, those are going to be your lines that it approaches but doesn't cross, right? A rational function is going to have a vertical asymptote. So what's nice about that is, given this function, how do I find vertical asymptotes? What can't I plug in is when the bottom is 0, right? When I think about 1 over x, I can't plug in 0. So I take my bottom, g of x is my bottom, and I set equal to 0, then solve. That's it. Okay? So to find vertical asymptotes, you set the bottom equal to 0, and you solve. There's another important step to this where you check it, where you plug it in and make sure it's not a 0 for the top. I'm not going to worry about that right now, because when we do the other steps, saying the top equals 0 is also part of the process. Next up, we got a horizontal asymptote. This one's a little bit different. This one you're looking for something that the function approaches as it goes off to infinity, but never touches, right? Okay. So don't worry about this in this class. A function can touch the asymptote and go up and down over it, but it has to approach it. So in this class, it won't touch it. But if you take pre-calc, it can cross it, and then it goes back. Okay? Do you guys mind? I'm going to verbally tell you something, but you're not going to need to know it for this test, but you might need to know it for a future class. Is that okay? Or do you want me to write it? Are you okay? All right. If I'm dealing with a rational function and the power of the top, like this is x squared and this is x, is bigger than the bottom, it does not have a horizontal asymptote. Because I want you to think about something. As I go off to infinity, I'm dealing with really big numbers. What's going to get bigger first, x squared or x? X squared. So x squared gets huge over a littler x, and that just goes off to infinity. So if your power on the top is bigger, you don't have an asymptote. If your power on the bottom is bigger, the bottom gets big really, really, really fast. What's a number over a really, really big number really close to? 0. It gets really small. So if the degree of the top is less than the bottom, your horizontal asymptote is 0. If g of x and f of x have same degrees, oopsie, Jiminy crickets. Oh, sorry for the language today. You just divide leading coefficients. All right. So what I mean by that, so we have an f of x over g of x. And let's say I have, do you guys want a number example or a letter-like rule? Anything I write, I would write, because this is the one we're going to use. Do you guys want two number examples? That's probably be better. So let's say we get 2x squared plus 4x over 3x squared minus 2,000. My degree on the top is 2. My degree on the bottom is 2. So that means as I go to infinity, these two are going to take over. They're going to get so much bigger than the other ones, they don't matter anymore. So what I do is I look at my leading coefficients. So that marker doesn't work. A pretty brown marker. So for my horizontal asymptote, I take my leading coefficients, and my horizontal asymptote is y equals 2/3. Okay? Like I said, this rational functions look scary, but the math behind them is very straightforward. Okay? I'll give you another one. Let's say I have 3 minus x over 4x plus 1. Are my degrees the same? They're both x to the first, right? So I'm going to rewrite this. Why? You don't have to rewrite it, but I'm going to rewrite it so that way it's written in the right form, so it's easier to see my leading coefficients. I'll draw a bar there so you know. What are my leading coefficients on this one? Negative 1/4, right? So my asymptote is y equals negative 1/4. That's it. And again, if you go up higher in higher level math, you don't have to write this. If I have like 4x over 2x squared, since the x squared is bigger, it's just 0 because it's going to be a fraction. Okay? So if the bottom is a higher degree than the top, it's always y equals 0. If the degree on the top is bigger, it does not have one. It has something called a slant asymptote, which you don't need to worry about in here. We're not going to deal with it. We're not going to deal with slant asymptotes. All right? So give me a second. I'll let you guys ponder that. All right. Oh, I forgot. I'm going to add something to this box because you probably have room. What's a horizontal line equation? It's always x equals something, right? Since I gave you an example here, I should probably give you an example over here now that I'm thinking about it. So if I have a function that's 2x plus 1 over 3x minus 2, right? What part am I worried about for the vertical asymptote, the top or the bottom? Bottom. Once the bottom equals 0. So I set the bottom equal to 0. And what do I get? I get x equals 2/3. And then I'm done. That is the vertical asymptote. Because vertical lines are x equals, right? Horizontal lines are y equals. That's the new stuff, right? That's the new stuff from this section. The rest of the section's old stuff, actually. Because when I graph, what things do I need to know? I need to know asymptotes for this, and I need to know intercepts, like Jake Browning. Guys, how do we find an x-intercept? What do? We set y equals 0. Okay? Now, here's a fun fact for you. If I'm solving a rational equation, do I have to worry about the bottom being equal to 0 if I'm finding out when it crosses the x-intercept? No, because I found it up here, right? So what's the only part I actually have to set equal to 0 for a rational? The top. I'm going to set the top equal to 0 and solve. That's all there is to it. Set the top equal to 0 and you solve. So really, when you see a rational expression, a rational function, and you need to say a lot about it, set the top equal to 0, set the bottom equal to 0, look at the leading coefficients, and then you're going to plug in 0. It's a 3. You're going to do 3 things almost every. You're going to do 4 things almost every time. So let's take this example again. What part, if this is my function I'm going to use, am I going to set equal to 0 to find my intercept? Do I worry about the bottom? You could, but when you multiply both sides by 3x minus 2, what happens to it anyways? It goes away. So algebraically, all I need to do when I see a rational function is set the top equal to 0 to find my intercepts. So this one I get x equals negative 1/2, right? Now, that's not a line, right? Be careful, because it's easy to be like, oh no, which one's which? Luckily, again, what do you guys get to use on your test? That's a point. That tells me the point negative 1/2, 0 is on that graph. Because we have a y value 0, and that's our x. And lastly, what do we need to find? Our y-intercept. Oopsie. And what do we do with that? Set x equals 0. This one's actually really easy too. You don't have to do math for it, but I'll show you. So think about it this way. We're going to do f of 0 over g of 0, right? We're just plugging in 0 to both functions and seeing what we get. Yeah. So you guys want to use this example again? That's a rational function. How do we find the x-intercept? What do we plug in for x? The amount of money in my wallet. Holy smogolies. What do I get? Negative 1/2. Which is a y, right? Because we're kind of thinking about this as y equals the function, plug in 0. So my y-intercept is 0, negative 1/2. All right? Phew. That's it. That's the whole unit. That's the whole section on one page instead of a lot of slides. Now, interesting things to keep in mind. What would happen if I get a 0? If I said this, I got 2/3 here, and I got 2/3 for an asymptote, what would that mean? It means that's a hole. That's a hole in the function. I'm pretty sure I didn't give you, none of those come up in the homework, but for future, if you take calc and pre-calc, that's going to be important. If those match, because how can you have an asymptote and a value for that function at that point? You know what I mean? You can't. So that's a hole. So it looks like there's a point there, but there's not. Like when I'm speaking, it sounds like there's a point, but there's not. All right. Do you agree that if I gave you each of these boxes independently and had you solve for 0, or that you guys could do it, right? What's the difficult part? Is doing all the steps, right? Let's do You guys have this chart written down? If you do, let's do a problem together. And then, honestly, that's about all I got. Could you have multiple vertical asymptotes? Could you have a bunch of them? Yeah, if you have a quadratic, right? Or because you'll have multiple times it's 0. I don't do that on the test. Could you have multiple x and y? Ooh. Could you have multiple intercepts? You can. You can. Are we going to have to deal with that? No. So given f of x equals, let's make it easier, 2x plus 6 over negative 5x minus 4. Why not? Why not that one? All right, it's a fraction. And here's what I want you to do. Describe the graph to me. That's what question I asked. Describe the graph. So to describe it, we need to find the ha, the va, the x, and the y-intercept. Horizontal asymptote, vertical asymptote, x-intercept, y-intercept. Because if I have those 4 things, can I graph this? 100%. Horizontal asymptote. What do I do for my chart? What do I do for horizontal asymptote? Set the bottom equal to 0. So I'm going to do negative 5x minus 4 equals 0. So what's that going to be? What's x equals negative 4/5, I believe? Correct? You know what I mean? I'm just doing some algebra solving. Add the 4, divide by negative 5. Am I done? Yeah. Yeah. That's my horizontal asymptote. So over here, I'm going to start sketching this bad boy. So at negative 4/5, there's going to be an asymptote there that looks like that. Okay? We'll call this 1. Any questions on that one? Bottom equals 0 gives you the horizontal asymptote. Let's find the vertical asymptote. What do I do for vertical asymptote? Any math required for the vertical asymptote? No. Are my degrees the same on the top and the bottom? Yep. Am I going to do that for you on the test? Yeah. For this class. Maybe not in the future. So what do I look at? The leading coefficients. So the vertical asymptote is y equals negative 2/5. Yeah, that's 100% right. Jiminy Crickets. Sorry, I'm in autopilot right now. That's why they pay me the big bucks. There, find the va and the ha. Yeah, because horizontal asymptote is your end behavior as you approach infinity. Guys, just change the letters. I'm sorry. Actually, you could probably graph it the same. Just call this negative 2/5, and then negative 4/5. There you go. Why though? Why is it? How about this? Let's conceptualize it so we don't make that mistake. So I don't make that mistake again. Vertical asymptote tells me a number that can't exist on it, right? It's going to be like a hole in the graph. So for vertical asymptote, it's when the bottom equals 0 because that's going to be a spot that I cannot reach with x. The horizontal asymptote is what happens as I go to infinity with that line. And when I go to infinity, these x's take over, and it's going to be the leading coefficient. All right, good. What else do I need to find? X-intercept? All right, let's do x-intercept. Why not? X-intercept, I'm going to set y equals 0. Now, do I have to set that whole thing equal to 0? Or just the top? Just the top. So I got x equals negative 3 when I solve that. Subtract the 6, divide by 2. Now remember, I have an x value and a y value for that, right? So that's not an asymptote. That's the point -3, 0. So that's -4, -1, 2, 3. So that means I have a dot right there. Okay? I'll put lines here. And then for the y-intercept, what do? Now, have you noticed with the y-intercept with rational, there's going to be a bunch of x's. Can't I just ignore those and look at my end? Yeah, you don't have to actually plug it in. Just look at the two that are numbers. I know it's going to be -6/4. But I'm going to do it just for fun because we're used to it. 2 times 0 plus 6, or -5 times 0 minus 4. Again, anything with an x will always go away for the y-intercept. So that's -3/2. So I get the point 0, -3/2. All good. You should notice that there's always going to be dots kind of across from each other. So this graph is going to look like this. Because it looks like 1 over x. There's always going to be ones that go over it. And that's my graph. Could I reverse? Let's try one other thing. What if I did this? What if I gave you a graph? Could you tell me some stuff about it? Yeah, you could. Let's do, how do I want it to look? One and -2. If you are given the asymptotes of a graph, could you estimate what the graph's going to look like? It doesn't matter. It actually, yeah, it intercepts asymptote. All right. Based on the information I gave you, could we get an estimate for what this graph would look like? This is just a quick hitter. What does the vertical asymptote tell me? That I have to have a 0 at -2 on the bottom, right? So the bottom has to have something with x plus 2. Because there's a vertical asymptote there. Okay? Ooh, we could even do this. You don't need the intercepts. Never mind, I'm not going to give you those. That's going to throw another caveat. You don't need them. If I have a horizontal asymptote at 1, what's my power got to be up the top? X. And the leading coefficient has to be 1 because that's what I denoted. So could I estimate a graph looking at my asymptotes and leading coefficients? Yeah. Would you guys like to see another one, or do you guys just want to get into it and try them? All right. That's all I got.